Hello everyone, welcome to this brief tutorial on compact Numa-aware logs. Today we will discuss the challenges posed by non-uniform memory access in microsystems and how compact Numa-aware logs can help improve performance. A log is a synchronization mechanism that enforces mutual exclusion between concurrent threads. Synchronization technique is a critical area in parallel software, as prior research has shown that the performance of such software often depends directly on the efficiency of the logs it employs. The evolution of the logs is tightly coupled with the development of computing architectures. Traditional computer systems have multiple processors or cores sharing a single memory pool. In contrast, Numa architecture is used in high-performance computing and server environments, where numerous processors or cores require large amounts of memory. To adapt to this nature, each processor has its local memory in a Numa system, which can be accessed faster than remote memory. While performance evolution shows that Numa-aware logs perform substantially better than their Numa-oblivious counterparts, some issues hamper the adoption of the former in practice, especially where Numa-oblivious logs can be implemented using a single memory word. Virtually all Numa-aware logs are hierarchical, so it cases below issues. Even when the log is uncontented, a thread must perform multiple automatic operations to acquire multiple low-level logs of the hierarchy before it can enter a critical section. To ensure portability, Numa-aware logs must be initialized dynamically as the number of sockets at the underlying system is unknown until the runtime. Hierarchical Numa-aware logs require space proportional to the number of sockets. The authors of the paper Compact Numa-aware logs propose a new locking mechanism. We can call it CNA. It is a variant of MCS that we can run in the course. Let us see how it works. There are two queues, the primary queue and the secondary queue. This is the biggest difference with the MCS algorithm. Let us see the node implementation. There are 4 fields. The thread can get the lock if the field span is true. The field socket represents the socket it belongs to. The field secondary tail is the references of the last node in the secondary queue. The field next refers to the node's successor. The first node in the primary queue will get the lock, then the manager will traverse the primary queue to find the first thread working on the same socket, and it will put the thread before it into the secondary queue. When there is no more threads belong to the socket, then it will move the nodes in the secondary queue to the head of the primary queue. But how to recurse the head of threads of the secondary queue? We can add a new field, but it's a bit expensive. We can reuse span field. Instead of writing 1 or 2 to mean the thread can get the lock, we write the head of threads of the secondary queue to mean now the thread can get the lock. How to ensure fairness? The authors say we can define a random generator. It has a very low probability of generating a special number. When it happens, nodes in the secondary queue are moved to the primary queue, even though there are nodes in the primary queue that belong to the same socket of the previous thread that who got the lock. This ensures all threads working in different sockets will get the lock fairly. And the drawback of this algorithm is that there is no fairness at the beginning. CNA addresses the challenge that the memory requirement will increase when the number of sockets increases in hierarchical Numa-aware algorithms. The authors implemented the new log in user space as well as integrated it into the Linux kernel. Their evolution using both user space and kernel benchmarks shows that the new log has a single-thread performance of the MCS, but significantly outperforms the latter under condition, achieving a similar level of performance when compared to other state-of-the-art Numa-aware logs that require substantially more space. The theory of CDN is not so hard. Okay, thank you for watching this video. For more information, please refer to the research paper Compact Numa Aware Logs by Dice, Def, and Alex Cogan.